At last year's Better Software Conference, I gave a presentation called The Big Oops, which was a historical analysis of a particular object-oriented programming technique. And if you happen to see this presentation, then you know that one of the central figures in it, in fact mentioned right at the beginning of the presentation, was a programmer named Marc LeBlanc, who was an early engineer at Looking Glass and was instrumental in the design and development of what we would now call an entity component system. Now, the way that I actually got all the information that I put in the presentation about that work at Looking Glass and the people involved, what they were thinking, what they did, and why, was I did an extended interview with Marc. I actually have known him for a long time, so when I was working on the presentation, I just wrote him and said, hey, would you mind sitting down for a few hours and just going over the whole thing with me, what you can remember about how this actually came about, so that I can give like an accurate account of what was going on. And that's, we did this interview. That's where all of the information came from. And by the time we got to the end of the interview, we were both like, boy, I wish we had just recorded that, because it would be this great sort of long-form thing that has all this information about early Looking Glass and sort of what they were doing at the time and what Marc's recollection of the process was. And so we were kind of both bummed about that, and we ended up putting it kind of on the to-do list to say, look, maybe sometime we can just sit down and do this again, and we'll both try to pretend that we didn't already have the conversation, because we did, but we'll try to recreate it as best we can so that we can put something up on the internet for everyone to watch, to sort of hear the full account and all of the details that were in there. I'm very pleased to report that last month we did exactly that. And this is the video that I've prepared. So without further ado, I hope you enjoy this long-form interview with Marc LeBlanc on the history sort of the entity component system and in general the programming that he did at Looking Glass on sort of object modeling and that sort of stuff. Why Marc? Let's go all the way back, because people will want to know your history. Why Marc? Let's start.
Good to be here, Casey. And people assume it's a Boston accent thing. It's actually not, and to pronounce it with a Boston accent is a mispronunciation. I went to college in the Myers-Carvey era of Saturday Night Live. And there was a recurring segment on there called Hans and Franz getting pumped with, or I forget what it was called, but it was like these two Arnold Schwarzenegger clones, right, called Hans and Franz. One of them was Kevin Nealon and the other one was, I think, Dana Carvey, right?
Yes.
And so they would pump you up. They would get you pumped up, and people just started calling me Marc because of that. And Marc, you are a girly man, that kind of thing. And eventually, at one point, like the entire campus got postered with signs that just said "Marc" on them.
Are you serious?
Yeah, and it was, and it kind of stuck from there. So that's what it is. That's why it's mostly just a screen name now at this point. But and in fact, I do have relatives who, as you know, like New England is actually stratified in terms of like the different accents or different class.
Yes.
And so my family was definitely like the sort of blue-blooded, my dad moved down from Montreal when he was 4, and my mom came out of the, Irish and Italian sort of.
Yep. Common Boston kind of thing,
working class, common Boston folk, and so they all, they have the Pak the Khan, those kind of people have the Pak the Khan Harvard Yard accent. But Massachusetts is also full of like these educated professionals, right? Because it's full of colleges, and it's these educated professionals who come in from out of state, and they go to college and they become doctors and lawyers, and they just never leave, right? And so there's like this whole other sort of professional strata of people who just don't have the accent, right? And so my family, my parents are people who moved from the working class strata to they were both like the first in their first generation to go to college. And so like we moved to a doctor and lawyer bedroom community. And so, I was parking the car as a child, and then I kind of got it beaten out of me.
The accent, the Massachusetts accent cast.
Very
few people are familiar with. Yes.
Yeah. Yeah. So I don't want to make the whole show about this, but
same thing with me actually. Like, we lived in a town that was mostly people who like came there from elsewhere and didn't have the accent. Literally, like, and it was this tiny town. There was a tiny town just next door. Everyone there had the accent, right? So it's like it's very
yeah, absolutely.
So anyway, that out of the way, pronunciation. So it's Mark,
like channel Arnold Schwarzenegger, not Mark Wahlberg, right?
So that out of the way, you started. Correct me if I'm wrong, but you started working on like 3D simulation games with Entity Systems, that sort of stuff, on like Underworld 2, like like right after sort of you might say what we might call the birth of this kind of game, like 3D plus simulation system, like a bunch of things coming together. For folks who don't know, like, because I only covered this a little bit in like sort of the adjunct to the lecture, like, tell us a little bit about that time. Like, how'd you get into that? Why were you even there? Like
why was I even there? That's actually a fascinating question. It was a long chain of nepotism.
Awesome.
So the story behind Looking Glass really is that Doug Church played D&D, dungeon mastered by a guy named Paul Shawcross, who is his own character. Paul Shawcross had an uncle. Paul Shawcross. There's another player at that table, Mark Sobkowitz, who had an uncle named Paul Neurath, and that's how the connection got made. And most of the players in the D&D game lived on my floor at MIT, and Paul lived on my floor, and Doug lived on my floor, and most of the players lived on my floor, except for one of Paul's old high school friends, who had an uncle who was in the game industry and was leaving Origin to found his own company, which at that time was Blue Sky. It's called Blue Sky, and that connection got made, and Paul hired Doug. And Doug then turned around and hired, I wasn't necessarily Doug, but like he referred John Mayera, who was on the floor, and Tim Stelmach, who was not technically on the floor, but hung out a lot. James Fleming was there. Dan Schmidt was there. All not necessarily on this exact one floor, but definitely all in that sort of group. And they did Underworld 1. For what was at the time Blue Sky. And at the time, I have a playtest credit in Underworld 1 because they were all, I was going over their house and playing the game, and there was the office. They had their office in New Hampshire. I forget where, but I think it might have been Manchester, New Hampshire. And,
right, it wasn't originally in Cambridge, right? Like Blue Sky was kind of off. It was a different thing.
It was off in New Hampshire where Paul lived, and then, but like there was a time during Ship where, like really close to Ship, where Warren came up. He was like he was still working for Origin. He was the Warren Spector. He was working for he was basically our publisher side producer, and he came out, and they rented like a single room in a basement of an office building in Davis Square.
Okay. Davis Square is a Boston like T-stop kind of location.
It's a Boston.
For people who don't know,
T-stop. So it's in between. It's like in between Harvard and Tufts, basically. So they rented this one bedroom so that the guys didn't have to drive all the way to New Hampshire to crunch on the game, basically. And so I would hang out with them in their little one room. I feel like if there weren't enough chairs to go around, I feel like Warren sat on a lawn chair, like a lawn chair lounger on the floor of this thing. And everyone was just kind of sitting on the floor in this one room, and I was playtesting just a little bit. I remember, actually, I was a TA for software engineering at MIT that year, and I remember I got tasked with, maybe I was late to a meeting or something, and I got tasked with assigning the students to classrooms. Like, it was beginning of the year, and like they were like, who wants to do this thankless job of deciding which TA gets which students. We'll give it to Mark, who's like the most junior guy and probably walked in late. And I was like, this isn't thankless. I'm drunk with power now, right? Like I get to hand pick my own recitation, and hand pick the one guy who's already annoyed me's recitation.
Yep.
So anyway, I did that work on the floor of that thing while those guys were making Underworld.
Okay, so basically, Underworld 1 happens because basically a bunch of people at MIT get hired through a D&D group.
Yes,
because they know how to program and they need more programmers. It's sort of basically what happens.
Right. And there's a little bit of another tangent off that we ought to go on, which is that if you Google the name Paul Shawcross, what you will probably find is that he is the one back during the Obama administration. He's now a space policy guy.
Oh my God, I've met this guy.
Maybe back during the Obama administration, there was a thing on the White House website where you could like submit petitions, and if enough people like voted yes, signed the petition, then the White House had to come up with at least an official answer. And there was a petition to build a Death Star that got the threshold. And
I think I met him through Doug one time. I totally forgot about that.
Paul Shawcross is the guy who wrote the official White House response to should we build a Death Star, and that was his 15 minutes of fame. But he was the dungeon master of the D&D game that basically created Looking Glass.
So anyone who's ever played anything downstream, Ultima Underworld, Thief, The Dark Project, but you have like...
Or any arcane game for that matter.
That's right. You basically have Paul Shawcross to thank. You just don't know.
Absolutely.
So you're there. You know these guys from MIT, and you're literally on the floor while they're deving it, like doing stuff. I guess they expand for Underworld 2, and so you are part of the team?
So my story was, I was visiting them all the time, hanging out, playing their games, stuff like that. I actually got sick of a feature in Underworld 1 where so Underworld 1 had a procedural minimap. It was, I don't know if it was one of the first games to do it. I mean, but you would walk through the dungeon and it would, draw the map of what you had seen, right? And there's this procedural system, right, that would, look at the tile map and look at what you'd seen and render something, right? So the Underworld dungeons were a height map, right? Tiled height map, right? And there was some slopes and stuff also, but and a tile could be solid, right? Right. So like there was solid walls, but then you could have variation of height within, right? And so it was not showing those height differences as walls in the minimap. So in Underworld 1, for example, there's a huge chamber that's a maze, but because the walls of the maze don't go all the way to the ceiling, like when you look at the minimap, it just looks like one big open room.
I see, right. And you're like, oh, I could just walk right through that. And you're like, oh, wait, I remember that's the maze. I can't do that. The map is just bad.
Yeah, and so I got pissed at that particular fact about the minimapper. And so I I was there in their office and I was like, all right, where's the code for the frickin' minimapper? And so I hacked in something to like show height differences of enough height as walls, in the minimapper. And that was probably my job interview.
Right. They're like, okay, we like that. It's good.
Yeah. So I joined Looking Glass part-time. I was part-time as Underworld 2, and I was still a student at the time. And I started as a sort of programmer working. I did all the new spells. I did some scripting support kind of stuff. And then I kind of got turned into a level designer because they needed level designers, and I did the ice caves in Underworld 2. So that's kind of where it started. And then, I joined full-time on like February 3rd of 1993 for System Shock.
Gotcha. So System Shock was your first full-time Looking Glass
Full-time
project.
gig, and I did take some time off during that to finish my master's thesis, which they weren't too happy about. But
They're like, everyone else here dropped out. Why can't you?
yeah. No, it was more about like
That's not true. There's plenty of people. It's a mix of.
It was a 21-year-old not managing expectations of his employer kind of thing.
Yeah.
Yeah.
Well, so we'll jump back there in a second because I want to talk about because this was part of the presentation. It was like the entity systems of those early games.
Right.
But just to put a button on that, also, can you give people a short summary of what you did after Looking Glass? We're gonna jump back to the Looking Glass part, but you've done a bunch of other stuff.
I was
since
at Looking Glass through System Shock 2. I think was the last product that Looking Glass shipped. Maybe not. Maybe there was a Flight Unlimited game in there. Technically, I guess Jane's Attack Squadron got shipped by somebody else, and that might count. But I was basically with Looking Glass till the last day, and then I spent a few years at Visual Concepts actually working on the NBA 2K franchise and also the NFL 2K franchise when that existed. I did a little bit of work on non-sports games for them, a little bit of prototyping work on non-sports games. Then that's where I met Andrew Leaker, who is a character. His claim, well, he has many claims to fame, but one of his claims to fame is having, as a young man, created with a couple of his friends the Sky Realms of Jarun tabletop role-playing game, and then went into video game development from there. So he was working on a thing. I met him at Visual Concepts. He left Visual Concept before I did, and he went indie, and he was working on a thing called Oasis, which was pretty exciting to me. I was starting to get frustrated with sort of the direction of Visual Concepts being mostly a sports game company. Right. So I was really excited about Oasis. So I kind of jumped ship and joined Andrew in completing Oasis, which is this weird cross between Minesweeper and Civilization. You can play it on Steam. It's called Defense of the Oasis because it turns out there's this pesky rock band that makes it hard.
Obscure rock band that no one's ever heard of.
Yeah, obscure rock band with a similar name that tends to dominate the Google searches. So so on Steam it's Defense of the Oasis, to be a little bit more narbacular. So I went to a company, company at the time, Andrew's company is called Mind Control Software, and we finished Oasis and submitted to the IGF and won the grand prize in 2004, which was very exciting.
I remember that game. I had a lot of fun with that game. I kind of, now that you remind me that it's on Steam, I feel like I can go play it again.
You could probably go play it again.
I forgot that I could even do that. Yeah, okay.
Yeah, it's on Steam. Defense of the Oasis, only for your PC, sadly, but someday maybe we'll get it on your Mac and your tablet again.
Thanks to Proton, it's also on Linux, I bet. I bet it'll run just fine. Yeah. But anyway.
I think it's okay on the Steam Deck.
Yeah, it probably would be. But okay, so after that,
so I was CTO of Mind Control Software for 10 years. It changed its name a couple times. We did all kinds of things, a lot indie stuff, mostly work for hire. We did an educational first-person shooter. We did an Advance Wars clone for the PlayStation Portable. We did the first implementation of the online version of the Pokemon trading card game.
Okay.
And also the Kaijudo trading card game for Wizards. And we did a bunch of stuff until basically a company went out of business owing us $1 million. And that, we scrambled for a while. But then, we closed our doors in 2014. I did a startup for a little while. And then I joined another small indie outfit called Riot Games.
Yeah.
Where
much like the band Oasis, very obscure. Some folks out there may have heard of them.
Thing. So I actually, I'll talk a little bit about my Riot career. I've never actually worked on League, which is kind of unusual for a guy who's been there for 14 years. But I started in a small outfit called, or a weird unit called Riot Shorts, which doesn't exist anymore. But it was modeled after Pixar shorts, and it was trying to be like, let's make brand expressions that are games. Um, and yeah, let's make brand expressions that are games. So Riot does music videos and stuff. Like, what if the music video was playable?
Playable in some way, yeah.
Some way, so yeah, we were doing small games, and I can't really talk about what I was working on there because it was never released. But that unit did release two things. One was a mobile game called Blitzcrank's Poro Roundup, which was basically an Atari 2600 Stampede clone, for mobile, and it also released the board game Mechs vs. Minions. So I did that. I've been working at Riot for 14 years. I'm in R&D now, working on future games that are not yet announced. So I really can't talk much about my Riot career, even though it's been quite long. But
all right, well that's a good like capsule summary. So now I'm gonna push the giant rewind button.
Okay.
And hop all the way back to Ultima Underworld.
Sure.
So, let's talk about entity system stuff. Because I feel like one of the really interesting things about our conversation last time was just that everyone talks about entity systems, but actually, like, you're one of the few people who's actually thought about them at the level of depth that you have, right? Like a lot of people, it's more just like, I'm just trying to get this thing that sort of works to do like basic stuff. But for you, this is kind of more of a, I'm not going to call it a lifelong passion. That might be a bit overstatement, but like, you've definitely gone way deeper into this particular rabbit hole than most people have. So maybe you can talk a little bit about the entity systems at that time as you remember them, and sort of bring us up through, kind of the part where the entity component system happened. Not that that's that important in any particular way, but just as a benchmark of like your thinking at the time.
Sure. Well, and you've got to understand in historical context, right? You got to understand things like the hardware of the day.
Yes.
Right.
And also the infancy of real-time game design.
And the infancy of real-time game. Yeah. Yes. All of that. You got to understand all of that. And one of the things that was, so at the time we're working on Underworld. Now, I don't know if this story is true, but supposedly, like, Looking Glass had like a demo of a Wolfenstein-y like thing in 1990, something like that. And basically a year before Underworld came out, and also a year before Wolfenstein came out.
Yes.
And the story goes, I don't know how much of this is true, and I may get the details wrong, but the story goes that Paul Neurath and John Romero were like on a plane together, like they happened to be on the same flight and sat next to each other and had a talk. I think it was Romero. It might have been Carmack, but I think it was Romero. And they knew each other, and hey, Paul, what are you up to? And like, we're working on real-time texture mapping. How about that? And Ramiro's like, oh, fascinating. And and then so they part ways, and then Ramiro and Carmack go off and make Wolf 3D, which was basically what the demo that Looking Glass had like a year earlier. But Looking Glass was, didn't really want to make the obvious thing you do with this is you run around and through walls and shoot things, right? They wanted wanted to try to do the world that supported that, right? Like a world that could like really make that come alive, right? Which meant, AI behaviors and RPG elements and, cool lighting and, all that stuff.
Looking Glass is kind of famous among those of us who like observed it more closer to the inside but weren't there, right?
Right.
It's kind of famous as the place that always like bit off way more than they could chew, and as a result were not as successful. Like, because they always tried, like, they had the talent to do something that would have sold really well.
right.
But they always were like, but we want to do the thing from like 10 years from now. We want to ship that today. And you're like, guys, you can't. Like, we're not there yet. It doesn't matter how smart you are. No one can do that, right?
Right.
And this is that was a sad fact of Looking Glass. But the plus side of it for the industry was that it was always a place that had all these really cool firsts that people took from, right? I mean, many people, it inspired a lot of people to watch those things happen, right?
Sure.
And they did have successful games as well, so it wasn't like they didn't. But anyway, I'm just putting that context out there for people who don't know.
Yeah, and also, though, like, the reason why Thief is not Skyrim, right? Like, the reason why Thief was not, like, you know, a huge story-driven open world, you know, extravaganza with like complex inventory management and, you know, lots of different, you know, nonlinear choices, and was more like a do the mission kind of game, was Looking Glass trying to get back to the not biting off more than they could chew. And it was still too much, right? But so let's talk about the hardware. Right. So the hardware that ran Ultima Underworld 2 was like, you know, the 48650s, like the 50 megahertz 486s were dropping. I don't think the local bus architecture was out yet for Underworld 2.
Right.
And so the other thing, so you have these 48650s, and you have this basically 8086 architecture, which was never intended to last this long, right? So, and the thing about the 8086 is basically what the original IBM PCs were, and later they were 8088s, but so this architecture had a segmented memory model, right, where pointers, generally speaking, were 16 bits, and you had a segment pointer which told you which. So now you have a 64K addressable space, right? And you had a segment pointer, right, which told you which of those, which was it wasn't even another whole 16 bits, right? It was like it was effectively another 4 bits, right? Because it was 16 bits, but there was overlap, right? And it turned out with the segment pointer, by moving the segment pointer told you which 64K you're looking at right now,
right?
And then you could use your pointers in that. And so if you wanted to make a big pointer, right? Like there was a far keyword in the far star in the C compiler that told you that this wasn't a 16-bit pointer. This is a pointer that had its segment address in it also. But even if you did all that, you had 20 bits of addressable of address space. So that's 1 megabyte, right?
Yeah. Not all of which is usable also, because a bunch of it's like reserved for like,
and there's a bunch of it reserved. But if you will look at the back of the box for Underworld 1 and 2, you will see that they require 2 or 4 megabytes. I forget exactly what it is, but it's more than a meg. Right, it's more than, and really in practice, it's really 640K that you have addressable at once. Yeah. And so there was a whole other like set of hardware to let you like move that 1 megabyte that window. So there was this like a 64K window inside a 1 megabyte window, and then you had a way to move that. Oh, I think the bottom 640K were always the same, and there was a way to like move the rest of the window around or something. This was extended memory, right? And so, you couldn't address a lot of memory at once, right? So heap allocations were kind of at a premium, right? You wanted to, you really wanted to, pack your stuff. You didn't want two blocks for two memory blocks for an entity. You wanted one memory block for an entity, right? Because you wanted to get the whole thing at once and not have to like move your window, right? So the entity system of the day was basically a fat array of every entity's I'm going to guess 256 byte block. And which meant that it was a giant union, right? Like, because different kinds of things needed different stuff, right? Like if the entity is a creature, then it's going to have some state about what its brain is doing.
And the aforementioned, severe memory constraints, like we do not want to have to like, hop around through memory to get this thing, also means like you're trying to keep that as small as possible, so you have to use unions. You can't just be like, well, every entity has, a modifier for how much, attack damage it has. Because if there's something that doesn't attack, we probably really wanted to use that place for some other value. Right. So you really have to lean heavily on unions in this era. You can't just be like, it says it's another 8 bits or something, who cares, or heaven forbid another 32 bits. Forget that. Like that doesn't fly, right? In this era.
Right. Yeah. So another example is and so another thing is like, you have like the bottom 640K was kind of sacred, and you had to be like really, really strict. I will never forget the day that Doug Church to me said, Mark, if you save 2 bytes 1,000 times, you've saved 2K. Right? Like
this is accurate.
He was like trying to impress upon me like the importance of, every byte counting. And it's possible, I don't know if this was what I was looking at the time when he said that to me, but so in Ultima Underworld 1, there was a spell you could cast which would teleport you. And the way you chose where you teleported to was there was an item. I think it was called the Moonstone or the Runestone or something. There was a magic stone, and there was a spell called Teleport to Magic Stone.
Okay.
Right, and you could you could literally leave the magic stone anywhere in the world, and it would teleport you there. Right. And so it could be on another level. Right.
Okay.
Right? And so this was the way this was implemented was, and this will impress upon like the premium of memory. The way this was implemented is there was 1 byte in the bottom 640K, which stored the level number that the stone was on. So when you cast the spell, we would load that level, search the entire level for the stone, and then teleport you there. Right.
Because you couldn't afford to store
the actual location of the stone. Right. Like 1 byte. And and if they probably, I mean, there were only like 8 or 9 levels, right? So if they could have found some use for the upper 4 bits of that, they probably would have.
Okay.
Right. So like that's an example, because one of the things we did in Underworld 2 was we changed it so that there were 2 stones, and when you cast it on one, it took you to the other. So I expanded that to 2 whole bytes, or maybe I did pack it into 2.
Maybe that was the time.
Maybe that was the time to use the upper 4 bits.
4-bit packing.
I don't remember.
Okay.
I don't remember that, but yeah. So like this is the world we inhabit, right? So things are a 256 byte block. And maybe there's some common stuff like position. Almost everything's got a position. Lots of things have a velocity.
Yep.
And there's 1 byte for your species, right? Like 1 byte for like, what kind of thing are you?
And that's sort of like a type field, right? Like it's like just who, anyone who needs to like switch on a behavior can use this thing.
Right. Yeah. You're right. You're switching on this byte. Maybe there was a subtype second byte, or something. That was kind of, and in my talk, I talk about, there was the story of I introduced a bug where, a lantern vanishes when it hits the wall because I implemented impact damage, and lanterns don't use their hit point byte for hit points. They use it for fuel, and so it was only an empty lantern. If an empty lantern hits a wall,
Right.
it dies
Because you
it
check.
took damage. Yeah,
Yeah.
and I needed to check whether like this was of a type that had hit points.
So does this mean if you threw a lantern at a wall that was fairly full of fuel, it would just fall down, and when you picked it up, it had less fuel?
Yeah.
Probably. I'm guessing
Yeah,
logically.
and in fact, I'm pretty sure I knew about that, and I just didn't think it through. Like I was like,
okay.
I was like, oh, should I deal with like, what about this bite? It's hit points or it's fuel. Like, is it okay if you lose some fuel if you hit a wall? Probably, yeah.
Yeah, I mean,
right?
it
Like,
spills a little.
It spills a little, right?
Yeah.
Like, a torch, gets a little busted, right?
Yeah.
And I just didn't think about the case of like, could you die?
Yeah.
Yeah.
Okay,
and it
so
would vanish because it just vanished immediately because it had no death animation or anything, right?
So this is kind of, I guess at this point, would it be correct to say that probably none of you are thinking all that hard about entity systems, because really you're just focusing on like, look, I just have to try and fit stuff into this thing. And during the development of those games, you're just doing whatever you can. Or are you already, even while doing that, going like, should this be something like, because I don't know. I mean, I really don't know what was your frame of mind then. Did the concept of thinking about these more broadly only happen later, or were you already in that mindset?
Well, no, we definitely needed the idea of, you need sort of like the capital E concept, right? Like we called them objects at the time, right? But you need that concept because you need a thingness, like you need a concept of a thing, right? So that you can iterate through this world and get all the things, or like you need some unifying base class, for lack of a better word, for like there's geometry, and then there's terrain geometry, and there's things, right?
Okay.
And you need some way to like talk about things in the abstract, right? Like species of things in the abstract, right? So one of the things that happened a lot in systems like, and this goes back way before Underworld, in like Ultimate games and things like that. One of the things that happened a lot was the authoring tools for logic would be built out of these entities, right? So like kind of like if you think of it like Redstone in Minecraft, or like a little bit like Game Builder Garage if you've ever played with that, where the way that it's like, I have a button entity that open and a door entity, and the button has the object ID of the door it opens, and it's like, and now I want to have a multiplexer entity because I want this button to open 2 doors.
Right.
So, like, instead of the button points at the door, it points at this multiplexer entity, which knows how to point at multiple things, right? And then you have this, like, generic idea of an actuator, and that can, and you can have AND gates and OR gates and XOR gates and all that stuff.
So
and
people kind of end up recreating computer logic inside the entity system just out of necessity, because
right.
designers want to be able to edit it in whatever tool they might have, or using whatever utilities they happen to build makeshift or something. Right.
So rather than like opening up some editor and typing in text in a scripting language, or typing in code, God forbid, like, because you don't want to ever recompile.
Right.
You would build, like, there was a lot of logic that was built out of these, what we called the trap trigger system, right? Which is like, there's entities that are triggers, there's entities that are traps. You can have traps that are also triggers, and all that stuff. So it's like, it was very easy to like, there's a switch that opens the door, there's a pressure plate that opens the door, there's a, something else that opens the door. Very easy to build that stuff out of, and it's similar to like what they have in like with Redstone and Minecraft, or with other things. I don't know if you ever messed with Game Builder Garage at all?
No, when you mentioned that, because obviously I was familiar when you said Minecraft Redstone. I've never used it myself, but I'm aware, like I've seen what people do with that and of the idea of it. Game Builder Garage doesn't sound familiar to me.
It's a Nintendo product. It's a Nintendo make your own games product. It has an awesome tutorial. But its approach to games, its approach to like authoring is less like, Scratch. Like Scratch is a very procedural, plug blocks in and things follow a linear order and there's branching and loops and, very programmy languagey. This is much more like a circuit model or a mechanical model where, it's like so for example, you can have a box which is a character, and the character might have an input pin that's like horizontal movement. And then you make a box that is the left analog stick and you wire it up, right? And now the left analog stick controls horizontal movement, right? Like, and so it's more like there's things that emit signals and there's things that know how to take signals, and so over time this thing is simulating, right?
Kind of a little more blueprinty. Maybe.
Yeah, well, blueprint again is still an imperative, right? There's an execution thread, whereas this is more like, this is just a box that's like
it's just flowing. Like the stuff is just flowing,
a flow, right? And this is just a box that's generating a signal.
Gotcha.
Yeah, so it's more like electronics, right? Like our analog electronics almost.
I see.
And it's a pretty fascinating way to think about, but it's kind of similar to what like the trap trigger, where you build logic out of entities.
So at this time on Underworld 2 with the entity systems, are you guys starting to think? So you are thinking of this sort of as a system, like you are kind of aware of that whole thing. You're not just like, this isn't just an organic thing that arose and no one's really paying attention. Like, no, we get that. But are you starting to chafe against it as well? Are you like...
Yeah, no, I mean, the whole union thing.
So you're all thinking like, this is kind of crappy. We want something better. We on the next time, like you having that feeling already on Underworld 2.
Yeah. Okay. So, we're having that feeling, and we kind of bring it to bear in System Shock. So System Shock, is the first time. So we have, this horrible memory model, right? This where we have like the smaller window inside the bigger window, right? Inside the whole RAM, right? Which is terrible, right? And then DOS extenders happen. And DOS extenders are things which run on top of DOS and let you have the full 32-bit address space, mostly by like doing the window moving for you. Although I think maybe there's other things going on. I think the CPUs are starting to have... Yeah, the CPUs are starting to be 32-bit now, and they're having like protected modes and things. And so it's doing tricks to like page protect and move windows and stuff. So you have a 32-bit operating system, 32-bit address space finally. So you can have more blocks and do more things. You still, don't have virtual memory. You still, you still only have the RAM that you have, and all of that stuff. So for System Shock, we were really chafing against the union stuff. I don't think we did any unions in System Shock. I could be wrong about that. Okay. But basically what we had was one block for the common stuff that all entities had, like position and maybe velocity, I'm not sure. Species, definitely. Type. And then we had for like each, if you have like this, this type space, right, you can imagine that's organized into like, genuses and families and, and orders. And so like, there was some strata of that. Let's say at the phylum level, we had just arbitrarily, so we had like species and we had phyla, right? Yeah. And each phylum had its own block its own schema, right? So
so if just to translate that, a little bit. So basically what you're saying there is I've got a type field. The type field is or species field in the parlance of Looking Glass.
Yeah, that's my parlance. I don't know. I think we probably
or whatever it was. Yeah, whatever it was at the time. We have a field and it's got some number in it, and that number is going to tell you something like specifically this is a cup, right? It's like this cup of hot chocolate, right? And we probably don't have a separate block type just for cup, but we do have one for like
household objects,
small objects that contain things, or like there's some kind of category.
That was probably actually cup was probably in the trash category, right? But
all right. Okay.
Yeah, so we have some high level things like weapons and monsters and probably a couple other things, right?
And so everything of type cup has one of those blocks because it's in that general thing, but all of the different things like cup and thermos and whatever, they would all have the same block type because they're all under that phylum. Only monsters or whatever and some other one get a different block type.
Right.
That's okay. Gotcha.
And so there's like one big array of the common blocks, right? Mm-hmm. And then for each category, there's a big array of the blocks for that category, right? And so like you look at the common block to see which other block you should be going and getting. Right. In fact, I think what it had was, right, so you had your object ID maybe had some extra bits in it, but it had an index into this big array of all the blocks, right? And then inside there was an index into the array, like your type, and an index into array of your category blocks, right? So like you would go to the main block and then you could reference into the category block. And that allowed us to, have... some things had a bigger block size than other things, right? Like the trash objects, maybe they're block, maybe they didn't have anything, like, I don't know.
Right. Like they just don't, because they're just trying to save space. So
yeah.
If I don't, So I guess I have a couple questions about that in fact, one of them, I guess we didn't really talk about when we talked last time. So I'll ask it this time.
Sure. So
one of the interesting things to me too is like, in our previous discussion, we did touch on sort of like, you kind of have a little bit of a different take on object-oriented programming. In fact, I quoted you in the lecture saying like, why does it have to mean this thing? Like, there's a lot of ways we could conceptualize it. There are a lot of people have conceptualized it. Maybe there are better ways. I want to touch on that a little bit because one of the things I've noticed that doesn't get mentioned at all in like your description of Underworld's entity system, in your description of System Shock's, there really isn't a lot of discussion there of like the sort of thing that a lot of people would say about object-oriented programming, where everything is supposed to kind of be opaque. Like, you're not really supposed to be looking at types. You're just supposed to have, like, blind dispatches and stuff. Could you give me a little bit of your take, and also maybe the Looking Glass take in general, on that part of it? Because it sounds like everything is still, like, I write some code and I know the types of things. Like, I can look at their types and make decisions on them and things like that. Can you just... Do you understand my question? I hope it's not phrased too strangely, but a lot of people think object-oriented programming means I call a function and I don't know what the type is of the thing, and that's what it means, right? Yeah.
Right. I mean, well, some of it is, the time, right? We aren't using C++. The System Shock is 100% in C. And we don't have space for vtable pointers. I mean, we got more space, but we don't and the other thing is we want to be able to do things like clone objects, right? And do things like that. And it's really, and serialize and save to disk and load. And we want to do very simple block copies of stuff like that. So we don't have any pointers inside, our object database. And we certainly don't have any vtable pointers inside our object database. I think that's a big part of it. There's probably some stuff around. I'm trying to remember. So Underworld 2 is right when instruction caches start being a thing. So in fact, maybe Underworld 1 is right when instruction caches. Underworld 1 had a bug on later hardware that had instruction caches because they did a lot of self-modifying code, right? Just stuff like, you have a switch, and instead of, doing a lookup in a jump table and doing an indirect memory access through a jump table to get your address and jumping with that addressing mode, like you laid out your things you laid out your jumps in a table, in regular spacing with no ups if you had to, and you just, and you just did arithmetic to figure out your address, and you self-modified a jump in like the next jump based on some arithmetic, and you just jumped straight there because that was way faster than doing a conditional branch or anything else, right? Or doing a table lookup or anything else. And there are times when we needed that in the renderer. And it broke. It broke as soon as instruction caches, right? And now all of a sudden, like, we have to invalidate the instruction cache, and we don't get the performance anymore, right? But yeah, so it was definitely of an era where jumping through a indirect pointer was more expensive than a straight jump, and like that was a real savings, right? So yeah, like we weren't doing a lot of function pointers in general. Like in some places we were probably, but we weren't doing it a lot. And so yeah, some of it was just that constraint. We kind of went hog wild in Flight Unlimited. Flight Unlimited was our first C++ game. And we kind of went hog wild, and it bit us in various ways.
Right. Yes. I remember you talking about how there were a lot of issues because since it was the first C++ project and people weren't prepared for the downsides.
Well, I'll tell the heap fragmentation story.
Yeah. Okay.
That's
yes. Please do.
Yeah. So we're using C++, but it's still DOS, right? We still don't have virtual memory. So we got what memory we have. And we discover, but we're using C++, and everyone thinks that when you use C++, you're supposed to, or at that era anyway, you're supposed to use the new operator a lot, right? Like, you just allocate stuff, and that's how you make objects, right? You use the new operator, and so we had a lot of little blocks in the heap, and we fragmented the heap, and we got to the point where there was enough free memory for the thing that you wanted, but it wasn't all contiguous, right? And you couldn't get that block. You couldn't allocate that block. Sorry, you couldn't new that object because there wasn't a big enough single block for it. And so we spent a little time trying to figure out if we could like re-architect around something better, and failed. And maybe there was time pressure there, but so the answer that we came up with was basically when you land the plane. It's still DOS, right? Which means that the way you launch the game is you go to your C prompt and you type flight, right?
Yes.
And you push enter, right?
Yeah.
And most of the time, that finds flight.exe, runs that, right? So what we ended up doing is we changed it so that instead of flight.exe, it ran flight.bat. Flight.bat was a batch file that ran the exe.
Okay.
Inside a loop. And so what would happen is when you landed the plane, we would do some inspection of the heap to decide if we were too fragmented. Maybe it was just like we'd call malloc with increasing sizes. I don't even know how we did it, right? But we did some check to see if the heap was too fragmented. And what we would do is we would exit the executable with a special instruction and a special return code. The special instruction told DOS not to change the frame buffer. We're exiting, but leave the frame buffer where it is.
Right, don't switch out of mode 13 or whatever. Stay whatever the mode was.
Yeah, whatever the mode, the graphics mode we were in, and leave what's on the screen on the screen. And we would exit with a return code. The batch file would see that return code and say, "Oh, this is a heap fragmentation case," and then it would loop back around, and relaunch the executable. Meanwhile, you're looking at a loading screen with no progress bar, right? Like you're looking at a loading screen with no progress bar, and it would relaunch the executable with a new return code saying you're coming, or a new command line parameter saying you're coming back from.
Yeah. Okay.
You're coming back from a refresh, so like don't put up all the loading, all the starting loading screens or anything. Just kind of silently sneak into the, the FBO, the landing the plane interface, and then we, so that's fine if you ever land the plane, right? So we did, and then we had to do another thing where, what if you just flew the plane too long?
Yeah, right. Yeah.
So we did another thing where like we would just occasionally like check your heap fragmentation status. And if your heap was fragmented, we'd like put a message up on the screen and say like, out of gas, emergency landing, and we would land the plane, so that we could go through that flow of like secretly exiting and restarting.
I wonder if anyone has a capture of that. I imagine.
Yeah,
no one
I don't know.
does.
I don't even know how often it happened. Like, I don't even know. Like,
I'm sure it's very rare because, like, I don't think I've rarely seen anything talk about that. So presumably, and certainly, it would never happen on a machine from today. You'd have to run it under intentionally set the DOS memory very small or whatever, right? Like memory footprint.
It probably only runs the DOS box anyway. So
sorry to interrupt real quick. There is one thing I wanted to insert here that happened after the interview that I think is kind of remarkable, and I just wanted to share it with you. One of the things I try to do a lot of times is I try to fact check things as much as I can. And when I was doing the presentation for the Big Oops, of course, I tried to use primary sources that corroborated each other and just, I didn't want to present anything that didn't actually happen. Now, if you saw that presentation, you know that there were a bunch of slides that I went over quickly during like a Q&A when I was asked a question. I said, I've got some deleted scenes here I can show you. In those deleted scenes, there was a thing about the Flight Unlimited sort of out of fuel thing that Marc had told me in the original interview. And I didn't fact check it at the time because I had cut those slides from the presentation. They didn't quite fit, and I felt that there was too much information about things that weren't directly related, so I had removed them. So I never actually tried to fact check whether this out of fuel thing actually happened. But now that I'm presenting this video with Marc telling the whole story, and he's talking about the Flight Unlimited thing, I wanted to fact check it. So I went and looked at the CD-ROM, the original installation CD-ROM for Flight Unlimited. I couldn't find any evidence of this, so I just asked Marc, I was like, are you sure that this was the case? I just did a cursory check of the CD-ROM, and I couldn't find it, and he was like, I guess, I don't know, like, maybe it got fixed before shipping, or maybe that's not the final CD. Let me ask the Looking Glass alumni sort of, mailing list, and see if anyone can remember. And he only got some vague replies. Someone was like, I did reduce the heap footprint a lot just before shipping. Maybe it got fixed, so we didn't ship it. I don't know. So no one was really sure. But Marc then actually went. He had a Flight Unlimited in shrink wrap that he happened to still have. He opened it, got the CD out, actually ran the installer in like a DOS box and looked at the final install, and there is the batch file. In fact, this is the batch file right here. So we did actually fact check this, even though it's hard to find. You can't really search for this on the internet. It doesn't seem to be a record of anyone actually hitting this or knowing that they hit this. I guess it was hidden pretty well. But here is the batch file. So it really did happen this way. They did have to ship a thing with a batch file that just would run Flight Unlimited in a way that would sort of fix that heap fragmentation. And so anyway, shout out to Marc once again for going the extra mile to make sure that we're putting out accurate information here, but it is exactly as he remembered it. We did check, and there it is. Anyway, now back to the interview. So going back to the entity systems then, so on System Shock, you kind of and this is sort of a solution to the unioning problem, right? It's like, look, we had these, just to be explicit, we had these problems where like we had to like do all this unioning, which presumably, like you were talking about before, makes it very easy to make a careless error because you're like, oh, I forgot that this field won't be there if I'm not this type of entity, and it's hard to catch those bugs sometimes. It's, you know, because you don't know which kind of entities that will end up, this function will end up being called on. It's like hard to think of them all, or someone else adds a new entity type that you weren't aware of, all those sorts of things. So the idea here behind the System Shock one, it's right, I think, is twofold. It's one, make it easier for the programmers to not have to like be so diligent to avoid that kind of error. And then two was also just to be a little more efficient because, hey, like you said, if monsters need this big block of memory, let's say, because they want to store AI state or something. Right. Now we don't have to have every entity in the game be that big. We can sort of flex size our different phylum, as you called them.
Right.
So monsters could take up a lot of memory and trash could take up very little. Right. And that allows us to scatter trash throughout the level without paying the cost of a monster and vice versa. Is that roughly like kind of...
Yeah, you know, I wonder if we were also... I don't remember. But we might have also been doing a thing where it's like, oh, now we can iterate over all the monsters, right?
Okay.
We have a flat array of, like, so it's like, oh, it's AI thinking time in the frame, right? I don't know if we actually did this, but it's AI thinking time in the frame. You know, it's bot behavior time. Let's run through all the monsters, and maybe the monsters had a point. They must have had a pointer back to.
I was gonna say that would require you to store a reverse, like some kind of reverse
index.
lookup.
I bet they did, though. I bet we did.
And I mean, you know what? You could have done it selectively. Like trash, which probably never got iterated over, wouldn't have to have one, right? But monsters, if they did, would. Yeah. So you could have done it.
We might have done that for a couple things. Yeah.
Someone who has the System Shock source code out there. Can we look it up?
I don't know where. I don't know where it is.
Okay, so that's up through System Shock, and in a sense, that means the System Shock entity system is not like a huge departure from Ultimate. It's sort of like a natural like upgrade, right?
Yeah, it's like a little bit of an upgrade. Yeah.
So then we go. Flight Unlimited is not really an entity system kind of game.
No, we had one entity.
There's Terra Nova, which happens in between here and Thief, but you weren't on that, or were you?
I was on it briefly.
Okay.
But Terra Nova, here's the thing. Terra Nova started during Underworld 2?
Really?
Terra Nova was a 4-year project.
Which at the time, like nowadays, people are like, "Oh, it's the GTA 6 has been how long?" No, but 4 years was massive back then.
4 years was massive, right? So Terra Nova came out in '96, I believe, but it started in '92 or '93.
So it might have had an Underworld 2-ish.
I think it had a very similar to System Shock. Kind of thing where it was like there was, the big block, the common block, and the, other things.
Okay, so System Shock-esque, like similar
it was
upgrade.
Probably System Shock-esque. It was definitely not. Anything like what we were doing in Thief.
So then let's talk about Thief. So this is the part where the entity component system kind of gets birthed a little bit for the first time. So how does this happen? Like, I remember you actually, when we talked before, you remembered quite a bit of it. I think you said there was like one or two places where you're like, I'm not sure exactly who the person was who thought X, but like, can you walk us through that process again, since no one else but me got to hear it?
Yeah.
Like, why are we thinking about this? Like, why weren't you just like, oh, we'll do the System Shock one, but now we'll maybe let people have two block? Like, why is it not just like we made another slight upgrade?
Definitely, we were definitely feeling constrained by the phylum, architecture, right? Like we were feeling like, having to make an upfront choice what the categories were, was really constraining. And I'm sure we ran into cases where we wanted to have, in essence, a toaster oven, right? Like, where it's both a toaster and an oven, right? it's not it's not an oven that provides the toaster interface. It's not,
Right.
a toaster that provides the oven interface. It's like both a toaster and an oven, right?
Gotcha.
And definitely. And we really felt like that was very limiting in terms of the decisions you could make, the kinds of things you could make, and just anything where you wanted something to have the properties of something, of another phylum. You kind of either had to like have it be two entities that are talking to each other, or fake it somehow. But I think we were really feeling constrained by that. We were feeling less constrained by the memory model, right? Because we knew we were Windows now. We knew we were Windows 95. We knew we had virtual memory. Right.
So you keep kind of, as we go from like Underworld to System Shock to Thief, we're getting more like hardware support for the kinds of experiments you might want to do.
More basically. Platform support for the kinds of stuff that we're willing to do. Yeah. And so just the idea of being able to mix and match. I think that Doug and Dan Schmidt was very, very interested in that. I think Tom Leonard, who was now on the scene, was very interested in that. And the memory constraints were different. And we realized also we could, instead of having flat blocks, like instead of having like big arrays, we could multi-pool, right? So we could have pools of blocks rather than flat arrays of blocks, and like a pool could have like multiple virtual memory pages in it, so we didn't have to like constrain ourselves to a fixed size per. I think the fixed size constraints we were chafing against, and I definitely think the like inability to like mix types we were chafing against, and I think some desire to make it less hard-coded, right?
I think last time we talked, you said like that was a big thing, was like you wanted to provide the people like at the time when you're like working on a level, you could just, without having to go ask a programmer, decide you wanted the toaster oven, because the programmers had implemented toaster and they'd implemented oven, and you shouldn't have to ask someone to get a toaster oven was kind of like
and that was a big part of it. And so another thing that we're laboring under, and it may be also because we're now in C++ instead of C, we're laboring under longer compile times.
The bane of C++, yes.
And we're laboring under very long link times.
Yeah.
We definitely had a desire to like do as much as possible between recompiles, right? And so we didn't want to have like the global list of all, like the 1 or 2 bytes that are all of the species that ever exist, right? We didn't want to have like the global list of all the types, and stuff like that. And we wanted you to be able to do as much as possible. We certainly didn't want designers compiling.
Right, like they want to add a new entity species ID, and we have to recompile the whole game. Is not on the table anymore. Right. Yeah.
Right. So gotcha. We didn't want them compile, and they would just suffer in the earlier days, right? Like they would just like wait for somebody to compile a new editor for them, right? And we wanted to less of that. And that was a big deal. Doing less of that. We wanted something where every designers could just author the whole thing, including the type database, including what existed. And we knew we wanted to be able to like, make entities out of Legos of some kind, right? Rather than, describe everything up front. Yeah. And that kind of led us to the property system.
So how does this come about? Like, you come off of System Shock, you know this, I mean, you've all been experiencing these things that you're saying you don't like, but like somebody has to do something, like somebody has to sit down and go like, okay, well, I guess we're going to try some stuff now. And what is that? Right. And so how does that process go? Right.
Yeah, that's a good question. So for one thing, we're not coming off System Shock, right? Like we're coming off of Flight Unlimited,
and Terra Nova.
Yeah. Right.
So System Shock's kind of back in the. It's like we remember this, but that was not what we just did.
Yeah. And so we have Terra Nova, which is like, a 4-year-old code base at that point, essentially. It's a 4-year-old architecture that we're trying to get out the door, and we have Flight, which was like our first adventure into C++. With essentially no entities,
right?
So we did have like a little time to think about this stuff, right? Like how we would do it,
right? Because there's no obvious entity system to now just take and use. Like there isn't like a thing like, oh, we're just going to roll this forward. It's like,
because System Shock is in C, right? And Flight doesn't have entities. Terra Nova's in C, right?
And 4 years old.
Yeah. Right. So like, there's no way to bring it forward, really. I mean, unless we want to write Thief in C, which we didn't want to do. Also, like, which was DirectX is becoming a thing, and like we're having to start to think about. Calling into COM interfaces and, stuff like that. So we kind of wanted C++ anyway. And we wanted to work with it, right? Like we wanted to be able to make subclasses and have polymorphism and do all the things that you do with, those kinds of programming languages. We just didn't want to do it in our entities. Yeah, I think this idea of like, hey, let's make something mix and matchable. Let's make something where a thing is a bag of properties, bag of blocks rather than a flat block.
And is there a touchstone for that anywhere? Like, I mean, I'm asking this question kind of very vaguely, but there's stuff like Infocom games where we've got this Lisp system and there's just crap attached to a list of, right? So, and I bring that up only because like Dan Schmidt, for example, is very like Lisp kind of programmer-y sort of person.
Right.
Like,
also a big interactive fiction guy.
Exactly. And so
maybe he got it from there. I don't know.
Yeah, and so is there like, that isn't the direction you end up going, but I know that there are actually experiments with that in there. So are people thinking like, oh, maybe we'll do bag of properties, maybe we'll do like how does that look, or can you not remember? I guess I know it's a long time ago.
Yeah, I don't know that I can remember exactly, but we knew that, well, I mean, I think you kind of get it from first principles, right? It's like if you know that we're not going to have phylum blocks, and that we're going to allow things to mix behaviors, right? Then basically every behavior is its own phylum, right? Like at that point, right? Like, and like, where do you go from there? And I'm not exactly sure. I kind of want to take credit for. I can't 100% be certain with this, but I kind of want to take credit for proposing the column major nature of it, where instead of Dan did an early version of the object system that was still a little bit like there was a global block E. And I think I kind of pushed back on let's try to do something where it's column major, by which I mean, rather than the entity is a bag that has hit points in it, hit points is a bag that has all the entities with hit points in it, right?
And I suppose you don't happen to remember why you wanted to do that, because that is the most unusual aspect of this system that most people don't try.
Yeah, I do think that that might have come from Doug, actually.
Okay.
Which is, I mean, I think Doug was very passionate about, there's just some stuff, right? There's just some stuff that needs to be in a big array, right?
Okay. Okay.
Like there's just like, positions, or, like there's just like some basic stuff, right? That like we don't want to like go looking through a hash map for the frickin' render model for this thing. Like that, that was the one definitely that like Doug was like adamant on. Like it's like when I've got an entity ID and I want to get the pointer to the mesh, right? I don't want don't want that to be a hash lookup. I want that to be a field select, an array lookup, something, of that order. So like we need to at least support that for at least some things, right?
So basically Doug is saying, look, you want to have an abstract bag of properties, maybe, but we're going to need some solution for how that's not how we get a bunch of performance-oriented properties.
Right.
And so you're kind of there thinking like, well, wait, how do we satisfy these two things? Like, how do we satisfy these two at the same time? Right?
Like to give Doug full credit, I don't think it was maybe, but I think it was like yes and, right? Like I think, I think that I think he was on board with properties, but but he was like, we have to I think like the default thinking was like, oh, we're just gonna have a linked list of your stuff, right? Like, right. And like,
Doug's like, no,
I'm not searching through no freaking linked list in the renderer for the mesh I'm gonna render, right? And so I think that so it's like, okay, well, do we have an authored pre-compiled block with like the sacred things, or do we have something else? So the something else was, we have column major. Some things can just be arrayed. Like I said, the mesh reference was a big array. And you strip off the bottom bits of the object ID and you look in that array and you go, right? Yeah. And some things like, oh, there's only 3 of these, on the level, or only 1 of these on the level. Like, that's, let's just have a linked list, that's fine. And some things, a lot of things were hash maps and a lot of things were, or like sometimes it was like, oh, the main thing we do with this is, iterate over all of them. Right. So it's a dense array of just, it's a variable size array of the things.
And does this come, like, I guess this is another thing that may be hard to remember in hindsight, but does this kind of pivot of thinking where it's like, oh, like, what if we tried this column major thing where, like, instead of always thinking about going and getting an entity and then trying to look at what the properties are of the entity, what if we think about our properties first and then say, like, what entities have this? Does that come as sort of a very... like, do you remember that being like, oh, wow, this is kind of working pretty cool? Like this works really well now that we're trying it. Like, did it feel like that? Or do you remember anything about, like, that experimentation process of being like, oh, wow, this is really interesting? Or was it, like, I don't know. I was just asking if you have any recollection. I think it was like the
looking glass biting off more than we can chew kind of thing. Okay. Where, like, we just knew it was going to work. Okay. And we just freaking did it, Okay. Fair enough. I could be wrong, but... Right. And we put in a lot of work to make it look to the designer like it was the other thing, right? Like we did a lot of work to make it look, you can go into the editor and look at this entity and browse it like it's a linked list of things, right? Yep. But we're really like asking every single freaking property in the world, like, are you here on this entity? Yeah. Right? And it's the editor, so who cares, right? So I know, I think that we wrote documents and we did some upfront design, but I think it was, I don't want to say it was waterfall, but it was definitely like, we're gonna build, we're gonna build the first. We're gonna build the first entity map, and then we're gonna figure it out from there, right?
Got it. Yep. Okay. That I see what you're saying. So it's very Looking Glass. It's like, look, this is just what we're doing. We're sure it's going to work. Right? And it's like, and then just like, and then we will make it work. Yeah.
We'll make it work. Yeah.
Yeah.
And
okay.
so the other thing that was kind of going on at the time was, Tom Leonard was a big advocate for COM. The component object model, not in the like Olay sense of, you're publishing things that other apps can, use or anything like that. But so if you think about, these days you have, what do they call it? The thing that's inversion of control. But what's the other word for what I'm thinking of?
Inversion of a different phrase for inversion of control.
Or that's not the thing that's not like resource location, but is dependency injection is what I'm thinking of.
Oh, okay.
Yeah. Like these days, we have dependency injection and we do all these like all this fancy stuff, right? Whereas, the idea of like, a resource locator, or a like it's like, oh, there's an API, there's a global API. I'm gonna go like ask for it, and I'm gonna get back an interface pointer to this global API. And so rather than like, I'm calling hard bound functions, I'm calling through a vtable to get to this global API, and there's somebody I have to ask to to know how is this API implemented today, right?
And you're saying Tom Leonard was an advocate for that basic concept.
That basic concept.
We're just going to kind of have providers of these services. And we're not going to they're not going to be like abstract, like Olay, like, oh, I don't know, or can you put it yourself in a Word document or whatever. But they're going to be basic things like, somebody give me a series of pointers that are this API, please. And I don't really care who it is. I'm going to call them. Yeah,
so there was an application unknown, right? There was the app unknown, and you went to it and query interfaced it for any particular, a thing that would be a singleton, right?
Yep.
Like the way you got a singleton is you went to this one, known COM interface, and I guess that was pretty common that was kind of like becoming the thing at the time. And so we had a abstract COM interface for properties. You could like talk about a property through an abstract interface. You could talk about its blocks as void pointers. You could, do all that stuff, right? So like some of it was like we were interested in this, using things like COM to like get singletons and stuff, And so like you could go to the property system and ask it, hey, you got hit points? Or even like, what are all the properties that exist in the universe, and get a bunch of COM interfaces, and that's how you could implement the editor and all that jazz. So part of it is like we were largely at Tom's encouragement, thinking in those terms also. And so we'd have I property and we'd have like I integer property, and I, some other, I float property, and you could query down to get actual, typed accessors for the common things. Obviously, like for the things that were structs, like you kind of were on your own. But
and is that something that you consider important to the system at all, or not really? Is that just like, hey, these were two different things we did? Because it doesn't seem like that's. It seems like that's not necessary for the row major part of things, or the column major part, I should say. Versus the row major
I think you need a way to iterate over all columns.
Right.
You need a way to iterate over all columns, and especially when you're going to write an editor, you need a way to, like look at do some stuff with a column.
Right. What's the name? What's the printable human name for this column that I display in an editor? Or
right? Give me the printable human name. Tell me what entities use it. Does this entity have it? Give me the. We had a thing. We had like a. I wouldn't call it reflection, but we had like a give me a. give me a dated description of the fields of this struct kind of thing that I can then use to make an editor type of stuff system. So like we could, like to call it reflection would be like very kind, but it was you had to like hand offer the data descriptions, and stuff like that. But we had stuff like that. Both for the editor and also for a little bit of like I think even we used it for scripting a little bit maybe, so that like in scripts we could, or I think there was something at runtime where we would like use it to like for designer exposure of that stuff.
So this gets rolled out as part of Thief, and I mean the entire editor is based on it. The entire gameplay, I assume, is also pretty much implemented in this system, right?
Oh yeah,
I mean, it is
yeah.
the whole thing. It is this, and I guess I'll ask two questions here. My first one is: so how do you feel that goes? Like generally speaking, like were you pleased with it? I mean, both at the time and in retrospect, or
Well, I think we did. We were able to like make a lot of cool stuff, and our designers were able to make a lot of cool stuff without our intervention. And I think we built a cool game. I mean, it fell short in some ways, and we ran into some kinds of pain. One of the big kinds of pain had to do with binary files, right? Like, everything. It just back in the day, all of our levels, all of our levels, all of our stuff is in, we can't use JSON or, or XML or like, we just don't have the disk space for like, a texture in base 64 or something, like,
right,
like,
sure.
so,
Yeah.
Everything's binary, including like the type hierarchy. And you can't diff and merge binary files, and all that stuff. So,
Oh, I see. So are you saying basically the problem was we have two designers, one designer adds a type, another designer adds a type. Now we have two different binary versions of the text file. Of the two binary files describing a type hierarchy that are not the same. What do we do? Like, how do we merge those?
Yeah,
basically?
yeah.
Okay.
I mean, and our answer was like we used hardware version control. In fact, like there was a physical object that represented, there was like the conch in
in Lord of the Flies?
In Lord of the Flies, that represented the type hierarchy.
What was the object? Oh my God, what was the object?
It was at the time, Nerf made a Nerf football that looked like a brain.
Okay.
It was it was like a Nerf brain. It was slightly elongated because it was like a Nerf football brain.
Okay.
But there was a brain that was the physical object that you must have the physical object in order to change the type hierarchy and check it into version control. So
okay, so in a sense, really, the binary fileness of it is not actually technically the problem. It's just that, hey, version control systems already existed and they worked on text. So had it been text, you could have leveraged them to merge. But if you'd had time, you could have written a binary merge if you'd wanted to.
We could have written a merge, or something.
But okay, I see. But you have nothing left because the source code control system is going to look at that binary file like, I don't know, they're two different binaries. Nothing I can do.
Exactly.
Yeah. Okay.
And in fact, so later on, somebody in the Thief mod community.
Okay, so this is later in time.
Later in time, Thief's out. Somebody in the Thief mod community decides that he doesn't like using the editor to make levels. And so he reverse engineers the file format.
Okay.
And he basically writes a library for Perl for generating level files using Perl. So he uses Perl as his level. Perl is what Python is today. It was.
Yeah. But he edits levels in Perl?
Yeah, he writes level generation scripts in Perl.
In Perl, okay.
Okay. And then then later on, someone else reverses the file format and writes a decompiler that decompiles levels into Perl.
Okay.
And then a fan mod group decides to use this as their versioning mechanism. So they're checking in scripts, Perl scripts, into their version control, right? They're using the level editor, and then you just decompile your level and check that in. That lets them diff and merge files.
And then you rerun the Perl script to generate the actual thing you load into the game.
Yeah.
Amazing.
Yeah.
Very, very fan mod solution oriented.
Yeah.
Yes.
So
Love it.
But they had better collaboration tools than us because of that. So we had the brain, and we had one of those hardware semaphores for every level, right? Right. So like, oh, I'm working on level 13. Like, I got to go find the guy who has the like Spawn action figure with level 13 written on it, or whatever.
Okay. So the brain controls who gets to modify the global type.
Type hierarchy.
And then the
like the level
Spawn
geometry
action figure or whatever is like things that are not global. They're only specific to level 14.
Yeah.
I see.
Yeah.
Gotcha.
So,
and if you are holding multiple of these, some real serious work is getting done. Like, I have the brain and level 14 because I'm doing some serious shit.
So the other thing that we did, and one of the things that I'm actually very pleased with about Thief was the link system, which to my knowledge really hasn't been replicated, including in my future work, right? Which is, in addition to this entity system, we had a system for first-class relationships between objects, right? So this is, so like we have now, like instead of like it's a column major thing where like you have like the entity ID is the key, now all of a sudden like it's a pair of entity IDs that's the key, right?
Right, like in database parlance, this is a linking table basically.
Yeah, it's a linking table, yeah.
Shows up in this, okay, and this is different than, okay.
Yeah, and so links have a flavor, which is basically like the table name, right? And they have source destination, and they have a little bit of satellite data you can attach. Like they have like a type. Like each link, each flavor, each table like gets to have a fourth column, essentially. So like with the properties, you could choose your own map implementation, essentially. So like you could choose how your table was indexed, because that like if a particular, you're going to be searching out from a particular entity, you want to make sure like source entity is indexed. And it actually changed the whole representation of the table. It didn't just, like we didn't just have like a table and indices, because that would be crazy in that time.
Right.
It was like, oh, I want this to be a, hash map of, like I want this graph to be a hash map of mapping source to edges, right? To an edge list, right? Or something. Or I want this to be just a list of edges. Or I want this to be a hash map from destination to incoming edges. Or I want both,
So it was kind of similar in approach. Then that system was sort of a microcosm of the larger entity component system idea, which is just like, look, I don't want to have to decide that there's one way that we're doing linking. It's like, if something's one to many, if something's many to one, if something's many to many, like I'm just going to want to pick whatever makes sense for this. And hopefully, you pick something smart so you think about it a little bit and go, this would be best described this way, and we go with it, right?
Right. So, but we used it for all the relationships. So like, and I go into detail on this, some detail in my talk. So like the relationship between an AI and the things it cares about would be links, right? Like the entities in the world that it's looking at or threatened by, or like those would be links, right? And like the relationship of that character to the key that's on his belt would be a link. Right.
Okay.
Like, one flavor, like I'm threatened by, I'm carrying, the relationship of like, I'm pretty sure like your character had like inventory links to all of the items in his inventory.
Gotcha.
And and when an AI is walking on a patrol route, right? Like the waypoints were connected by patrol route links, and all that stuff.
So this was pretty heavy. This was like a very heavily used system.
Heavily
then.
used.
Basically, everything that has more than one entity involved kind of sounds like.
Yeah.
Yeah.
Everything. You never stored an object ID as a field. You never had a property with
I
an
see.
object ID in it. Like that was considered like
Bad form.
bad
Yeah.
form. You always used links. And this meant that in the editor, we could like browse all the links. You could like just turn on link visualization for, any kind of thing in the editor. I think we had it in the game too. And and you could just sort of like look around, that meant that like all of this editing interface was available to all kinds of relationships. And you could also query bidirectionally. Like it might be slow, if you didn't, represent your links in a way that was optimal for that, but you could do it if you had to. And we basically did everything. In fact, the way we spawn the player at the beginning of time is there's the other thing is like types are entities, right? Like types are entities with negative entity IDs, right? So
You might want to explain that a little bit because I didn't touch on that in the lecture at all, and also like I remember this being a different thing from like when we talked. So no one's gonna know about that part.
Yeah, all right. So
you don't have classes and instantiations of classes.
And
it's all one thing.
no.
So why don't
it's
you
more like a JavaScript prototype chain, right?
Yeah,
so like,
give some background on that.
If Larry is a guard, right? If Larry's species is guard, it means that there's an entity called guard with an entity ID, right? And Larry has in fact, the inheritance graph is built out of these links, right? Like Larry has an is-a link to the guard entity, right? And when we query, what is Larry's maximum hit points, we look for it on Larry's end. Like first we look for it on Larry's entity, and then we go follow the is-a link to see if anywhere in the chain of is-a links has that property, right? So the entire inheritance graph, so types are entities, and the entire inheritance graph is built out of this link system. There's a cache, right?
Right.
Basically a path compression cache. So basically we would hop up to your species, and then your species would have a path compression cache for any property that it, so it would know which entity to go to get that property, which meant that we didn't, it could be type agnostic, right? Like we didn't have to know what type that thing was to cache it. We weren't caching the whole, like if it was a big memory block, we weren't caching the memory block. We were just caching like, where is it, right?
Was this was this actually like a heavyweight implementation kind of thing? Like were the designers allowed to change things in that graph arbitrarily? So like suddenly we have to invalidate the cache because somewhere in the is-a links, like somebody decided to add this property that didn't used to be there, or was that like not allowed, or you know what I'm saying? Because this could get pretty complicated if you wanted to go all the way.
There was probably some like occult way to do something like that, but it was not really exposed.
So it's more frozen, like that hierarchy is kind of more frozen after the designers are done with it.
The hierarchy is frozen, right?
I see.
And so like we could cache inside the hierarchy all we wanted.
Because only Larry is changed. Like he may change.
You can say Larry's not a guard, Larry's a dog now. You could absolutely do that.
Right.
Got it. And we would never cache on Larry. We would only cache on Larry's species. So if you moved Larry from guard to dog, the cache would just work. Right.
Got it.
We did also, is that right? That's probably true. I don't think I'm lying. We did have this concept of meta properties. Which I talk about in my talk, which is like, so there are types, right? At least types, right? Like have these relationships, right? But then we had these other kinds of things that were so like species are like nouns, right? Guard is a noun, and person is a noun, and tree is a noun. Like so, like what noun? What noun are you, right? But there was also like what adjectives do you have, right? I am a hairy guard. I am an unconscious guard. I am a right, like I am an aggressive guard, right? And those were also first class entities in the hierarchy that had negative, and a second hierarchy. So we had a hierarchy of nouns, hierarchy of adjectives, right? They all have negative entity IDs, so we know that they're abstract, right? And so a thing could have like one is a relationships, but many has aspect or has meta property, I think is what it was.
Okay, so you were expected, like the system expected you to be, when you say is a, you get one of those.
Yeah.
But the other ones are like tags. You can just sort of stuff as many as you want on there, and that's fine.
And
but
it's all links, right?
Right.
And there was some kind of way to order the links. Like I think, because a thing
for precedence.
A link can have a fourth column, and I think so. The fourth column was like the sort key, so that like we could do a consistent topological search for your thing, right? But those relationships could change at runtime, right? Like I could be like Larry could be a hairy guard. He'd have a link to an is a link. He'd have a has meta property to guard. He'd have a has meta property link to Harry, and we could at runtime snap that has meta property link, and he's no longer Harry, and he doesn't have any of the properties in that hairiness bag anymore, unless he gets them somewhere else.
He's been shaved.
He's been shaved
suddenly,
yeah. And we could also like do the other way. You could just like make a link to Harry, right? And suddenly, and that's in fact how a lot of AI behaviors and states were done that way, right? Like aggressive. Like you want to make a guard with like designers would make a guard aggressive at runtime by like giving it this new aspect, which was a whole bag of properties, not just like a single field or a single, and that means, and someone later could go into the editor, not at runtime, not at game time, but at edit time, and like someone could fix up make changes to what it meant to be aggressive, right? And in fact, like unconscious was a thing, and so like when you blackjack someone, it just gets the unconscious meta property, and that contains all the behaviors. It like overrides the brain of the thing, right?
So this might be a good time to ask then, because I wanted to bring this up at some point, since in the Big Oops lecture, I very specifically quote you as saying why did object-oriented programming get this sort of trapping of like, it has to be a hierarchy, like a type hierarchy that matches the domain model exactly, or like you have this kind of way of looking at it. And I guess this might be a good segue, so that system that you're describing is like very different than like how C++ exposes its concept of inheritance and things like that. And C++'s concept may very well be a one of the places where that kind of, in your opinion, I think, not to put words in your mouth, your opinion of like the negative kind of object-oriented programming that's too constraining, where that comes from. So I guess I'll say, so is that sort of what you mean by that quote in a way, or is that like one of the things you mean by it was like, look, if I was going to design something object-oriented for designers to work with, it looks more like this, or or this is a good example of what we mean. Could you maybe like go from there, or give some more context to that quote, and because it seems like this is sort of in that direction, what you're describing.
Right. So we don't want guard to be a class, right? Like we don't want the decision that there's a type called human, and and guards derive from it, right? We don't want that decision to be compiled into the code, right? We're okay with that decision existing, right? But we want to give designers power over it, right? And so we don't, they could have built, and they did end up building a hierarchy that was, very domain model-y, right? Where, like guards are humans and which is weird, right? Because like guards aren't necessarily like a guard
It
dog.
could be an orc, right? Or
It could be an orc. We didn't have orcs, we didn't really have a lot of non-humans. So
you had zombies, I think, right?
We had zombies,
like,
yeah.
Okay, yeah.
Zombies
And fish people, but that was a later game. That was not the first one, But yeah.
Yeah. So
okay, continue.
Yeah. So we, didn't want those kinds of decisions to be, those kind of decisions to be like carved in stone, and you always have the problem of like, what point in the hierarchy do I put this? Right, like it's like I have some new, like you have like some class hierarchy that's like, like matching your domain model, and it's like, okay, where in there do I put like this fact, like, oh, suddenly like these two things, I put it here, but suddenly this thing over, elsewhere in the hierarchy, wants that fact too, wants to share that. So now I have to move it up, right, and to their shared ancestor, right, and then you keep moving out. Suddenly you have this like object class that's like got every kind of thing, right, and so we definitely didn't want, like, we were happy to model the domain model, right, on some level. We just want to do it at runtime in some sense, and we don't want to be limited by decisions about like what goes where, right? So this made it very easy to do that. Now, whether the designers felt that, whether the designers felt locked into their decisions, like I couldn't ask you. Tim Stelmach might be a good person to talk to about that. But so we very much wanted those decisions to be in the hands of. We wanted the domain model to be the domain of the designers, and not something that C++ knew anything about. So yeah, as you can kind of tell, like this means that we have like all right. So we have a link system, we have an entity system, we also have an inheritance system, right? Like we have a right, and in fact, like so inheritable things were called traits, right? So you could, like most inheritable things were properties, right? But you could theoretically, like, make some other thing that was a trait, and and all you needed to do was tell the inheritance system, like, whether this particular thing had it intrinsically, right? And then it could be a union of multiple properties, right? Like,
right, because inheritance in this parlance is just a search, basically.
Yeah, it's
like, look, I am going to search this graph using rules that resemble how a human family tree works.
Yeah, like how how a type hierarchy works, right?
Right. But otherwise, it doesn't really matter.
And in fact, probably it did support multiple isas. Like you probably could make the toaster oven with multiple isas. We probably, like the editor, maybe not. Maybe the actual link implementation didn't allow that. Maybe that like the actual like underlying table implementation like was an array.
Gotcha.
It might have been that, but like we could have changed that implementation, and then you could have toaster ovens, and the inheritance graph search system would just work for that. And this is kind of a segue to the next thing I want to talk about.
Hit me.
Which is a thing that we didn't really see the full potential of.
Okay. When you were doing Thief, you were
we were doing Thief. We built a thing and we used it, but we didn't really see the full potential. We built a thing called Act React.
Okay, do you want to set the stage for that a little bit? Because I think last week you said Ken Levine asked for something, basically.
Yeah,
and
so
this
Ken
was
Levine
your response.
pitched this idea, and you can kind of see this idea in some of the BioShock games. Ken Levine like pitched this idea of like, like sort of rich simulation where like, I could, I could set something on fire. and then I could, use water to put it out, or I could, I could. I think one of the examples is like, oh, there's a puddle of oil, and I could like walk through it and then set my footprints on fire. So it's just this idea of like there's all these phenomena. Like some fancy interactive fiction games work this way, right? Like there's a lot of like, or like a Dwarf Fortress kind of thing, right?
Yes, Dwarf Fortress very much so.
What this thing is made of interacts with what that thing is made of in a combinatoric way that can produce like all kinds of crazy results, right?
My arm gets a disease which causes the hand to fall off, which someone puts in a soup, and then the people eat the soup and they get the disease. Like these kinds of like crazy.
Right. Yeah. And I think maybe, Dwarf Fortress is an example of like kind of what we wanted to do in a game, like not quite that, because like that's a very like semantic-y kind of thing. Like how can you do that at a in a like guy sneaking through a room level, right? And you can kind of see some
worlds.
of that in like I said, some of the BioShock games, like him trying to like sort of push that further. So we built a system which we called Act React, and the idea behind the system was that there were phenomena. We called them stimuli.
Sorry, I don't mean to interrupt you, but
yeah,
I just wanted to add one thing because you corrected me on this the last time we spoke.
Right.
Act React sometimes gets confused as the entity component system.
Right.
And you said the dark object system. Is the actual name for everything we've been talking about so
far. Yes.
And Act React is what you're talking about now.
Is a new thing, is a yet other thing that we built on top of all of that.
Yes. Okay. So sorry, I just didn't mean to interrupt. I just wanted to make sure everyone knew it because I remember from last time, but I think that is a misconception.
So there is a type hierarchy of a phenomena. Fire, frost, holiness was one of ours. Water. Wetness or whatever you want to like, electricity, all of these things. There's a type hierarchy of, and then there was some things like there was, fire and there was holy fire or something,
But is that a combination or is that its own different type?
It might have been that holy was a meta property on, on these things.
Yeah, right.
So like there was a type hierarchy, and these were entities, right? Like, and you could create sources of these things in the world, and you could create receptors for these things that responded to those things. So kind of like in a trap trigger or redstone kind of way, you could say, when I get exposed to fire, I take damage, so a phenomenon had an intensity. I take damage in proportion to the intensity, or I take damage in proportion to the intensity with this scalar on it, right? Like all that stuff. Like I'm, really vulnerable to fire. I'm not very vulnerable to fire. All that stuff. When I take damage, I run this script, when I get exposed to fire, I run this script. When I get exposed to fire, I die. When I, all kinds of, like, and there was like a little, like it was like trap triggers where, there was a list of effects you could pick from, and like one of them was always like, oh, go out to the scripting engine and like do something
custom. Like we want something custom here.
Yeah. But there was a bunch of there was a handful of like just like common behaviors, right? And then there's these sources, stimulus sources, and there's these reactors. I called them receptrons. That's my fault. But so there's sources and receptrons, which are like a neuron that like when I get stimulated, I fire, right? And those were attached to entities, right? And then there's also propagators, which are things that transmit the source to the receptron. So like And I think maybe propagators, I don't remember if propagators attached to the source. I think maybe there's also third-party propagators, but like...
Which is like a volume that like, oh, this is, if things can be aerosolized, they can transmit
Yeah,
through
yeah.
this
So
air
it's like,
or this pool of water. Or...
yeah. So I think it was could be specified by the source. So it's like, I am a source of fire and I propagate it to anything within a certain radius of me. Or I am a source of fire and I propagate it to anything I collide with. Or I am a source of fire and I propagate it to anything that's in the same room as me. Or anything that's in the same, like, some volume as
Gotcha.
me, all of that stuff, anything in the same medium, as me. So there were a bunch of different, like, propagation mechanisms that you could specify. So like you could make so like the water arrows transmitted, like it made an explosion of water, of this water stimulus that the torches know to respond to and get put out by. But other things might care about being wet too. It's possible that like hitting someone with a water arrow, like ticked its drowning logic for like one tick or something, because like maybe that was done the same way. So there was this whole system where like things could be bearers of phenomena, things could be receivers of phenomena that behaved in certain ways. Our entire combat system worked that way, right? So like arrows were bearers of pokiness, and
okay.
and
Gotcha.
Swords were bearers of slashiness. Like we had the like D&D like bludgeoning, slashing, piercing concepts.
So someone could be hardened to one type, but
Yeah,
not
hardened
the other.
to one type of thing and not the other. I think there was a special phenomenon that the blackjack, like the KO.
I can kind of see what you mean, because like Thief, one of the things I was going to ask before is like, Thief in a lot of ways probably wasn't the best game for any of this, because honestly, like Ultima Underworld was the game for this, probably, right?
Yeah.
And like, yeah, and
some
so
RPG was probably the game for this. And the thing that was more than we could chew, really though, was the presentation side of it, right? Like I built the logic for all that, right? But like like a propagator really needs to think about how it's going to render and show to the player that it's propagating, right? The responder
they have no idea,
really needs to think about like how it's telegraphing its response to the player. And yeah, there were like, lists, there were things you could put in the list like play this visual effect or like stuff like that, but like I think to do that right, you need to like contemplate not just that these things are logical concepts, but that they are presentation, like to have take a holistic approach to the presentation, which we did not do.
Right, because the player needs some way to learn that these things are even happening. Otherwise, to them, it might just seem like some random stuff happened, and all this logic is wasted, basically. Right?
Yeah. And so, like, we kind of wasted it, right? Like, the mod community loves it, right? Because it's like,
because they can run with it now.
They can run it, because it's like it's like Trap Trigger on steroids, right?
Right.
I think they love it. Mod community folks, like when you watch this, like comment, get in the comments, and tell us if you love it or not. But
okay, we'll watch we'll count the pluses and negatives.
Yeah, absolutely. Right. Yeah, so we didn't really, Warren would say like you guys put Act React in the game, and I can't see it. Right.
Yeah, I think I had that same experience playing Thief, is that like, because I didn't actually know a lot of this at the time. I mean, obviously I knew a lot of you guys at the time actually, but I only, Doug had maybe told me, some smaller portion of this.
Right.
And it like, when people play that game, they focus a lot on like the stealth aspects of it, and like how it felt that way. And it wasn't easy to see all of like the richness that could have been there for things like that. And so I feel like that was like, you started this off by saying like we didn't really take much advantage of this, and I can understand that because like the game kind of like focused on other things in terms of how it presented itself to the player.
Right. Yeah, well that's true. But also like I think we would have liked to have, more like, because we did do a lot of like environmental stuff, right? Like we did do a lot of like, I'm gonna, grab this crate and put it over here and stack up 3 and make a little staircase and climb over this wall and end up in a place that nobody, like, we did have like we were trying to do like that emergent stuff. And if we could have like had more complex tools, like made that into some kind of pliable clay that the user could have created new effects with, we would have loved that, I think. Gotcha. But we didn't get there. And so what we did is we built a system that, in every other game is just like, if damage type equals piercing, then blah blah. Right. Something that's like an array lookup. A similar thing happened to me in working on the sports games. I was working on essentially the television presentation engine for the sports games. And one of the things we were doing for the first time in the versions of those games that I worked on was we were like recording the entire, like we were making a game long log of all the events of the game so that we could like, have commentary called back to it and, what happened earlier and just generally like have, like the television presentation be able to understand the whole history of the game.
So we can say things like, "Oh, that's his third quarter of the game. Like back in the second half, he missed that one," or that
right,
kind of
right,
thing.
Exactly. And it's like the problem with that and is like, any line of dialogue like that could have been, especially since at the time it was like we're not using AI to generate the speech, right? Like these at best were like, recording partial lines of dialogue and sewing them together, and we actually had some pretty cool stuff going on there. But that exact example it did of like, he missed that exact shot in the second half, or in the second quarter, like. You could implement that as, a variable for when was the last time I took that shot, and a variable, and a couple custom trackers for, this exact line of dialogue, right? And so like any individual thing you said that was backward looking at the history, the user can imagine it just done as some bespoke thing. Right.
I see.
Like, and so like how many things do you have to do, bespoke looking things do you have to do before it looks like, it's like a problem of induction, right? Like before it looks like, there's something deeper going on there. Right.
It's kind of not leveraging, right? It's not, you're not getting much leverage out of the work because it ends up being much more, it perhaps had a lot more capabilities than people could perceive, therefore it becomes wasted.
And maybe it actually made our bespoke things a little easier to author, right? Like there might have been that, right? But and similarly, like Act React, once you have it, makes your combat system easier to author, but but so what? Like we could have just made a combat system, probably, So yeah, I think that was a place. It did, it did kind of inspire the entity IO system in the source engine and a few other things, but it was a thing that we bit off, but did not so much chew.
So maybe that, speaking of I assume there's a bunch of people who went to Valve who were ex-Looking Glass. I assume the DNA carried forward.
And Chris Corello and a bunch of other folks. Sorry, all of you ex-LGers that I forgot.
Brian Jacobson too, right?
Jacobson, I guess. Yes, that's the one. That's the one.
But anyway, and Chris Green. There's so many. I keep thinking because there's so many, right?
Yeah,
but Doug was there too at some point, but working on VR, I guess. But anyway. So this might be a good segue, though, into kind of future stuff, because you kind of wanted to talk about like ideas you've had since then, or because it's probably been a hot minute since you've actually done Entity Composer.
If I can just share briefly, and actually this is a little bit of a segue. If I could just briefly talk about the Act React system,
Sure.
in terms of implementation, right? So we have a source and we have a stimulus. You have a type, a phenomenon. I called it a stimulus, right? So this is a source of fire. Both of these things are entities. So of course it's a link, and I am a stimulus of, I'm a source of link, right? Attached in the fourth column of that link is like how I propagate, right? And then likewise, I'm a receptor. I'm a receiver of this thing. So my receptron is a link, right? But sources and sinks essentially are things that you want to inherit through the type hierarchy, right?
Right, because you don't want to have to say each individual entity has it, because the point of the inheritance system is like,
Right.
if guards are always a source of fear for something, then you want all guards to have that, not, you don't want to say each individual guard is the source.
So this is an example of a trait in the inheritance graph searcher system that isn't a property.
Right, it's not like
it's
a number.
link. Right, it's a link, and it also uses the system. It also closes over the entire chain, because you don't want to, like, if I have some behavior, right? If I have some behavior on this phenomenon, another thing probably might want to add a behavior, right? Like, so by default, behaviors are additive, right? Like, I don't override your behavior. I have a new behavior that is additive with your old behavior, right? And so, like, when we respond to something, we search all the way up the hierarchy and gather all of those in topological sort order, right? And we start resolving them. And I think, and how do we? I don't even know. I think we ended up using like prologue style cut fail.
Okay, why don't you mention what that is?
Yeah. So, basically
this is so Looking Glass right now,
yeah,
Mark.
Yeah.
Oh my God.
So basically, like, we had, on our list of possible responses, we had basically break, right? We had like, don't keep searching through the hierarchy. You're done now. Right. So the way you overrode a behavior is you say, do my thing, and then break. Right.
Yep.
And cut fail is a thing in Prolog that is how you the way you say, like, because in Prolog is an inference engine, and you can't say something is false. You can only say, like, or the way you say something is false is you say, when you try to determine whether X is true, fail and stop looking for more rules. Right. So cut is stop looking for more rules and fail. Right. Yep. And so you can't. Yeah. And that's how you do that. So that's the reference to that. So let's talk about what's on my mind. A lot of things are on my mind. I want to say, first of all, that, like, I've been thinking a lot in general, about sort of how we make games in general, and sort of and how we program computers in general. Like,
okay,
we have massive waste, right? Like,
sure.
I open up 1,000-line source file. I type 74 keystrokes into it. I run the entire 1,000 lines through the compiler, right, as if it's never seen them before.
Yep.
Right.
Yep, sure.
And then once I like it, right, I tell the version control system to find the 74 keystrokes I just typed, and send that up as a patch, right?
Right.
And it's like, I just typed those. Couldn't you just have tracked them? And we're like, stuff is, we do all of our work on the assumption that computers are cheap and engineers are expensive, right?
Right.
And that's sort of true, right? But and this kind of gets to um,
Sure.
your stuff, which is hey, if your thing's going to run on 50 million phones,
Yeah.
right? And you can spend an hour making it run a second faster,
Yeah.
all of a sudden, that's different, right? But I've been thinking a lot about, with respect to, I don't know if this is a good segue, but I've been thinking a lot about invariance and how I can't talk about my current work, but a lot of what I find myself doing is managing invariance. Let's say you have hey, look, in this contiguous block of memory, there's 9 floats, right?
Mm-hmm.
And those 9 floats happen to be a rotation matrix, right?
Okay.
I know all kinds of things now about there's all kinds of things I can do knowing that that's a rotation matrix, right? If
Right.
I want to send that to you over the wire, I'm not going to send 9 floats, right? I'm going to send 3 angles, right? Or something,
Mm-hmm.
right? Or I'm going to send some bit packed representation of a quaternion or something, right?
Mm-hmm.
But we do so many things. But I'm going to call so many API functions that are going to do the naive, this is just 9 floats thing,
Mm-hmm.
right? And so and the fact that it's there's this invariant, right? There's all these invariants to do with what a rotation matrix is. And anytime you have an invariant, not only is an opportunity for bugs, right? It's oh, if I poke a value into this and make it not a rotation matrix,
That's a bug. Yeah.
that's a bug, right?
Yeah.
And then there's all these things I'm going to send these 9 floats over the wire to Casey. Do I, is there anything I can do to send, so off times, I just end up sending 9 floats to you, and all that stuff. And, I kind of wonder. I kind of wonder if we're, because we make this code and then we discover the invariants later, right?
Or rediscover them, you might say.
Yeah, or rediscover them. Yeah,
Yeah.
it's like, oh, when I typed this in, I didn't realize the matrix was going to be a rotation matrix, right? And so and my opportunity to do all of the optimizations around that is lost, right? Because I didn't know, right? And so I kind of wonder.
Or I might state that a slightly different way and say, you also might be reusing something. It's more efficient for me to reuse this thing that just does 9 floats, and I don't have the time to go.
Yeah, absolutely.
Make the one that actually obeys the invariant. So, right?
well.
I didn't know, but same result, same end result.
Yeah, I'm happy. The computers are cheap and I'm expensive, right?
Yeah.
And and I kind of wonder, I feel like just over the hill, there's some other programming paradigm where we're not making the 9 floats. We're making the invariant. I almost feel like, we want to make Michelangelo's David. And what we wish we could do is get a big block of marble and carve away at it until we had Michelangelo's David. But instead what we have to do is take an empty room and start piling up mud in the middle of the room, in vaguely the shape of a humanoid, right? And then eventually we are lucky enough to maybe start to work on the surface, right? And all of we had to do all this work on the interior of David's abdomen that no one's going to see and we didn't care about, right? And it's is there some way that we can, I don't know, I feel like somewhere over the horizon, there's something that, somewhere over the horizon, there's something, and this maybe just me, just going off in tangents. There's something that lets us move from the, ceramic sculpture to the marble sculpture. I don't know. Maybe it's we're supposed to do what we're doing and use AI to find our invariants for us, or something. I don't know the answer. But one of the things I've been observing lately is there's a lot of contexts where we want to copy the world.
Okay.
So, for example, if we're making a machine player that wants to look into the future, right? Like if you're making a machine player for chess, right? It's going to copy the chessboard and mutate it. And, maybe it's going to parallelize by making lots of copies of the chessboard and mutating all those copies, right?
And this becomes sort of its own problem of like, okay, so how do I compactly represent changed versions of a chessboard so I can have a lot of them or whatever?
Exactly. And so like that's just one example, right? Like there's things like I want to, there's a dumb thing in WoW, right? Or in a lot of games where it's like, oh, I have in my inventory like a magic weapon, right? And I want to be able to mouse over it and see two views of the world. Like the view in which I have my current weapon and the view in which I have this magic weapon equipped, right? Like WoW has this interface, right? Where it's like, here's what your stats are right now, and here's what your stats would be if you dropped your other thing and used this thing, right? Oh, this one goes up and this one goes down, and like, so that's like, we can think of that as like, we're looking at two different worlds, which are only different by this little thing.
But one could imagine, just to emphasize that last point you made, the way that's typically implemented is taking the shortcut of the fact that equipping a weapon can't really change much. But in our conceptualization of all games that could possibly exist, one could imagine the weapon that, when equipped, dramatically changed like even the shape of the world around you, or like what other people thought you were, and all these other sorts of things. So
Legends of Runeterra has a thing like this, where it is a magic-like game which has like effects on a stack, and it has a thing that you can mouse over, which basically like, show me the world after all this resolves.
Exactly.
Right? Yeah. And so it's like, thinking. This entity is destroyed and this entity is existing and this entity has, changed its numbers, and, like arbitrary things can happen, right? Like, show me this alternate universe that's the future. Right.
It's exactly like the chessboard thing. It's like, we want to know all of these things.
Yeah. It's like, I'm doing the look ahead as part of my user interface, right? Yeah. And then there's things like, in networked multiplayer netcode, right? Like, we have all these copies of the world. We have the copy that I am a player am looking at. We have the server's authoritative copy of the world. We might also have the server's copy of what it thinks I'm seeing, right? And
my copy of what I think I will get from the server,
right?
But might not be correct,
right?
There's all sorts
of that stuff, right? And so, I'm imagining an entity, and ECS has gone in a direction where it's very much about data-oriented architecture, right? Where it's about we want to cluster things together so we can iterate across them fast and generate lots of entities. And I'm not speaking to that specifically right now, but I think that there is a future where we contemplate all of that as a kind of inheritance through time, right? I was talking about this inheritance graph search engine, right? Imagine an entity system where the world is immutable. You never modify the world. Instead, what you do is you make a new world out of the deltas of, from the previous world, right? And that gets you, and then we have we have essentially these links, right, that aren't but are was
Right.
right. And so so like over time you can see, and maybe you don't need the whole history. Maybe you compress at some point, and you have some event horizon past which you compress, but over time you can see the history of the changes to this object or this entity. I can I can have two different worlds, and I can do I can essentially diff to, I can have two different branches, right? Two different disparate branches, and I can diff them by searching back to their common ancestor, right? And then I have a path from one to the I have a path from one to the other, right? And I can essentially diff any two worlds, right? As long as they have a common. Obviously, don't have a common ancestor, then their diff is just like everything, right?
And in this case, what we mean is it's sort of, I mean, I guess depending on how it's stored, this may mean sort of all the entities have to do that routing.
Right.
Effectively, right? In a sense, because we may have many of these chains. It's not, unless the world is literally just a serial set of bonds, which it might be.
Well,
I guess,
okay, so.
But yeah.
I mean, to telegraph a little, right? Imagine, so if a world is immutable, right, then imagine you have, so in Thief, we have an ID mapped to some properties, right? Imagine that's not an entity. That's just I've been calling it a jot, which is basically that is let's say we have an ID with some properties, and that's just a collection of claims about an entity, right? And an entity is a union of these things. It's an aggregate of these things, through inheritance and whatever else, right? And so a world, right, basically, so and now an entity has a name, Fred. A world says which jot represents Fred, right?
Okay.
Is a map from entity names, if you will, to these jots, right? And so if Fred doesn't change, then the world doesn't change. Then that if I have two worlds, right? I can, and that world is just the delta of which entities changed, right? I can see Fred changed, but Barney didn't. So this world has a new entry for Fred. It doesn't have a new entry for Barney, right? Has a link back to that world, right? So I can look at this world and see which entities on that world change, and then I can follow that link to Fred, and look at its links to figure out what was different about if I want to diff two worlds, what was different about it, and
so there's sort of in the same, so very similar to the dark object system, you're basically talking about something where there is some primal enumeration of all things that are tracked.
Right.
Basically.
Yeah.
And then in each sort of state of time, I'm saying here is the top level, the top level reference for each of those.
Right.
That lets me unpack what its state was at that time.
Right.
In two worlds, if this person hasn't changed at all, then it wouldn't change that particular thing. Although, to be fair, at least taking your description of the dark object system and assuming that was what was going to happen, that doesn't actually mean that the state of the entity didn't change. It means that the state of the entity qua entity didn't change. It's some of its inherited meta properties may well have, because they would be a different jot, right? So I can't really tell that this particular entity changed or didn't. It's just its rules about how it's constituted didn't change.
Well, I mean, assuming that you limit yourself to a frozen type hierarchy, right? If you edit the past, then all bets are off, right? But if worlds are truly immutable, and a world really just represents a state of a point in time, and there's no going back and editing the past, right?
Well, or I'm just saying more like you said, you could just say like we don't. Anything that can be inherited can't be edited or can't change. I just mean more like, hey, at this point in time, guards became evil.
Right.
As a category, well, what was his name? Larry?
Yeah.
Larry, he appears to not have changed between these two because he still has the exact same description.
Right,
I am a guard.
Right,
but his actual, if you actually wanted to evaluate him, he is different now because he inherited from guard.
Sure.
If, however, you can't edit those things, then yeah, I agree, right? Because he would have had to have switched.
But there is at least a record that guards became evil, and you could. So you'd have in the world, you'd have some,
forward propagate, yeah,
and you could search backwards,
certainly,
to Larry from guard,
yes.
Assuming if you assume some things about the kind of graph I'm describing, right?
Yeah. Yes, it is knowable. It's just not trivially knowable, I guess, is the thing I would say.
One of the things that really inspired this line of thinking for me actually was working on games like Magic: The Gathering. We worked on Pokemon. We worked on Pokemon. We worked on Kaijudo, which is kind of baby Magic. And we were talking about we actually had a bid. Mind Control had a bid in for the Magic Rules engine. But just thinking about, I don't know how familiar you are with Magic, but it has
passingly. I mean, I've played.
It has buffs, right? Like like you can say, like all creatures are blue, and you can also say blue creatures get +1/+1, right? And so like you have all these passive effects, right? And they have so like you have sort of like the explicit state of the world, which is like this card is on the table in this position, right? And then you have, and it has these numbers printed on it. But then you have the implicit state of the world, which is like, oh, this is what these numbers are after all the buffs have modified them, right?
Yes.
Like this is a classic thing that you run into, like buff systems are a classic thing you run into in games, right? Where you end up doing things like, you end up like having the like rerun all buffs thing where like we reset the entity back to tabula rasa, and then you run all these functions on it, these mutators on it, and now you have like, and then and there's all this pain around like when you do that, and and all that stuff. And I don't know that this obviates that pain, but it does allow you to contemplate the explicit world and the implicit world as different worlds that you could diff between, or whatever else. And so, for example, and so one of the nice things about that for something like netcode, right, is like if I can diff two worlds, then that's what I can send. Like I can just send you, a diff, rather than having to like. It's not like we're tracking all the state and then we're running a literal like file diff on the world, like we're like running through all the binary state, like doing equals comparisons to get this minimal thing to send to you. It's like it's kind of emerges from the way you just build the logic, right?
Well, you're just kind of saying, look, we're making the changes. Right. So why don't we just record the fact that we made the changes?
Right. Which I guess gets back to my
changes,
74 keystrokes, thing. Yeah. Sure. So it was coherent. Good for me.
I was following you
so
anyway.
That's kind of what I'm thinking about, and I have a lot of detail I could go into on that, but I kind of want to build the thing.
Okay, and you don't have occasion to do so in your current project, I guess?
Eventually,
probably,
it's one of those things where it's like I'm kind of a gunslinger. I help out a bunch of different R&D projects, but it is part of my mission to sort of like come up with stuff like this, and at work. So maybe.
Yeah. Well, thank you very much for coming on and talking about everything. It's been a pleasure, just like it was the first time. I'm glad we recorded it this time so that other people can listen.
Nice. Yeah, it was fun to do it again. And do some more.
Well, before you go, can you tell people, like, I don't actually know, so can you tell people a little bit about, like, are you going to do a lot of stuff on the YouTube channel? Like, where can people find you? Or do you want them to find you? Let's start with that. Do you want people to find you, and if so, where?
That's a good question. I am Algorithmancy Tube. You're going to have to spell that
I'll
out
put the link in the description for that one for sure.
I'm Algorithmancy on Twitch. I haven't been streaming a lot lately. I do need to finish playing through Black Parade. Most of my streaming is me playing out games I worked on or some version of that. Like I streamed the entire System Shock remake. So I didn't work on the System Shock remake, but I worked on the original. So I did a original dev reacts stream.
Oh, that's cool.
Okay. I'm doing a one for do you know what the Black Parade is?
I don't think I've ever heard of that.
It's a Thief mod. It's essentially a 10 mission Thief prequel. Done as a fan mod. But it was only released in like 2024 or something, or 2023.
So very new, really.
It's a relatively new Thief mod, and I have been playing through it. Though I haven't, it's been months and months since I've done a mission, and I think I've got like 3 more left or something. But it's all on my YouTube channel. Cool. Also, my I did a few shorts about math on my YouTube channel, geared at more like high school students who are asking what's the Pythagorean theorem good for.
Okay.
And
gotcha.
Video games is the answer, of course. So most of my stuff's on YouTube, or also 8kindsoffun.com is all of my game design lectures.
We didn't really talk about that, but for people who don't know, obviously you've done a lot at the GDC. Used to have class every year on game design, right?
Still do.
Okay.
I've done it. I think we just did the 25th. This year.
Okay.
So it would have been the 26th except for COVID.
Right. Yeah. Okay.
But yeah, we've been
almost continuous.
Yeah, almost continuous game design workshop at the GDC, and you can find kind of the materials from all the past ones up on that website when I'm good at putting them up. It's the digit 8 kinds of fun. All of my game design talks, maybe a programming talk or two. But all of my game design stuff. And also on my YouTube channel, you can find the talk I gave on the Thief object system.
That one's actually very interesting too, and like very relevant to all the things we talked about. It kind of gives the overview of how things worked. So I'll definitely include a link to that one. In addition to the other links at the bottom for people who want to jump straight to it.
Absolutely.
Well, Mark, thanks so much for joining me. Hopefully we'll do this again sometime.
Thanks for having me, man. And maybe we'll hang again sometime. We'll see.
Definitely. Thank you for joining me for this interview with Marc LeBlanc. I hope you enjoyed it, and if you did, I have another video with Marc that I'll be putting up shortly, where he actually, to this interview, he brought some code snippets that had nothing to do with the thing we were talking about. He just had this kind of cool thing he wanted to show that he had been thinking about recently. It's really neat. It's about how you pick from a set of items randomly, and he kind of shows this new technique that is really interesting. It's a different way of framing kind of an old way of doing things that I absolutely loved. So I made that into its own separate video, and I'll be posting that shortly. And I'll be posting a number of sort of paper walkthroughs where I go through all of the original papers that I use to sort of construct the narrative that you see in that presentation, The Big Oops. So if you're interested in the full historical context, I've got a bunch of videos that I'm preparing on each of the different paper sets that I will be posting in the run-up to this year's Better Software Conference, where I'll be giving another computer history presentation, which I also hope you'll join me for. If you want to keep track of all of that or any of that, if it interests you, you can always find it all on my website, computerenhance.com. And if you're interested in following Marc or seeing what he's up to lately, you can look at one of these websites here. He kind of has some different stuff, depending on whether you want his YouTube channel or his game design stuff that he does with the GDC. And I'll be putting all of these links in the description below, so you can always just head down there and click on the one that you're looking for. That's it for now. Until next time, have fun programming, everyone, and I'll see you all on the internet.